Hey everyone, Jeff here again for RhinoCorp Technology. In this video, I'm going to be introducing you to the ENSA LHB-D series of commercial LED high bay lights. Now, high bay lights are typically used in situations where you have a very high ceiling or high roof. If you think of situations like warehouses, factory units, indoor sport facilities, manufacturing facilities, things of that nature. Now, these are traditionally lit with gas discharge lamps like this guy here. Now, these work okay, but there are, let's say, a few disadvantages, or a number of very large disadvantages when you think about it. The first of which is that they're quite bulky. Now, this globe here doesn't actually seem that bad, but when you consider that you then have to add a ballast on the back here, which is going to add probably about 5 to 8 kilograms of weight. You then also need to add a reflector on the outside here. And these units typically, when they fail explosively. So on the bottom of that reflector, you're now going to need to put another glass sheet in order to capture the glass fragments for when this explodes. Now, what else is bad about them? Well, they require frequent relamping. Okay, so what do I mean by that? Well, essentially they get dull really quickly. So one of these lights will typically drop to around about 50% brightness in probably 3,000 to 4,000 hours if you're lucky. So if you consider how long these are usually turned on in buildings, you're probably expecting to have to replace them or relamp them every year. Otherwise, what you're going to find is that your light level goes way down, okay? We're down below 50% after 4,000 hours or after a year. Another problem that we run into with these lights is that they're very inefficient, okay? So while metal halide in general is not actually that terrible, metal halide's around about 70 to 100 lumens per watt. Unfortunately, you then have to add your ballast, and your ballast is going to sit there consuming energy the whole time, maybe 30 watts of energy the whole time. In addition to that, you're going to lose quite a lot of light because unfortunately, we're not just taking the light directly from the metal halide lamp itself. We are also taking light from the reflector. It's going to have to bounce onto the reflector in order to hit the ground. Now, as you can imagine, that's going to introduce quite a lot of loss. And when you add all of that up, you're probably only looking at 40 lumens per watt at best. And as I mentioned just before, you're going to lose probably 50% of that over a year. So they're going to output less light, but they're not going to draw any less power. So your efficiency instead of 40 lumens per watt is down around 20 lumens per watt, which is pretty gosh darn average. The last big one is that these lights take forever to turn on. Okay, so when you go and flip that power switch on the wall, energy goes into your ballast. Your ballast triggers a little igniter, which then passes a high voltage spark through the quartz element on the inside of here, which allows an arc to form, which starts to evaporate the metal inside, and that metal has to evaporate and the pressure has to build up inside that quartz element before we actually start emitting light. Now, obviously that process takes quite a while. Anyone who's ever done it probably notes that it's at least 3 minutes, probably 5 minutes before there's a usable amount of light coming out of one of these. That gets even worse when you consider when we lose power and turn power back on, this thing has to cool down before the light can be restruck. Typically, there's no method for hot restrikes on these lights. So what you find now is that not only did we lose our 3 to 5 minutes initially, but there's probably going to be another 5 minutes stacked onto that we're going to have to wait. So we're talking 10 minutes. Forget about the safety implications of that for a minute. Well, if you consider that a brief power glitch will knock out all the lights in the facility for probably 10 minutes, just consider the inconvenience factor. Okay, so if it's going to take 3 to 5 minutes for this light to turn back on after I turn it off at minimum, right? Assuming it's had time to cool back down. Guess what? I, as the end user, I'm just not going to turn it off. I'm going to leave it on the whole time. So we've just discussed how inefficient these things are. And not only are they inefficient, but they're also turned on all the time because it's just inconvenient to turn them off, because when we turn them off, we have to wait for them to come back. Enter the ENSA LED high bay light. Now, high bays, LEDs in general, I should say, LEDs have come far enough now that they basically can overcome all of those gas discharge lamp problems, okay, in this particular scenario at least. And what that allows us to do then, or what that means, is that we can overcome each one of those issues. So the first of which, obviously we mentioned, was our bulk. These units are quite small when you consider there's no ballast that we have to attach on here. It doesn't look like much when you compare it to the globe, but as I said, there's no additional ballast, no additional reflector. Everything is built into one unit here. So that's bulk. Efficiency, okay? This 150 watt LED high bay, ENSA LED high bay light here can output more light than a 450 watt metal halide high bay light system. So 150 watts versus 450 watts, okay? And that's when they're both new, when this is new. Obviously, as soon as this ages a little bit, this is, you know, stratospherically more light than what's coming out of this traditional metal halide light here. So just to be clear, 150 watts, 450 watts, 1/3 the energy that this guy here consumes for more light. Kind of a no-brainer to replace these things, yeah? One other thing that makes it a complete no-brainer is the maintenance. So as we mentioned earlier, these things are terrible for maintenance. We have to replace them often, okay? Really, you should be relamping once a year in order to keep your lux levels up on the ground, but no one does that, so you just end up with dull lights. These ones here are almost maintenance free, okay? You might want to get up there and give them a wipe, but really you shouldn't have to do anything with these for more than 10 years in most applications. And over a 10-year span, this guy here is probably going to drop less than 20% in output, okay? Compared to this, which is going to drop 50% in just a year, okay? Complete no-brainer from a maintenance point of view and from an electricity point of view. However, I think the biggest thing I've left till last, the biggest deal for me, at least, is that these ones, these LED high bay lights, you can turn on and off instantly. Okay, there's no waiting. You don't have to worry about, you know, having to wait for gas discharge lamps to heat up and cool down or whatever. No, you turn them on, they're on. You turn them off, they're off. And if you turn them on again straight away, guess what? They come straight back on. No requirement for waiting for the gas discharge lamp to heat up. Now, why is that such a big deal? Well, obviously, like I said before, there's the safety aspect, but there's another huge thing. What that allows us to do is add occupancy sensors. As I said before, most of the time in situations with these lights, no one's around, okay? You might have a massive warehouse and no one's in most of it for most of the time, but guess what? Those lights are still burning. In these situations, because we can turn the lights on and off instantly, we can add occupancy sensors like this ENSA PS4 here and save even more energy, okay? So we're already dropping to 1/3 the energy consumption with this going to a standard high bay light, or this LED high bay light here from a standard light. And then we're going to reduce it even more. So if there's someone in that area for only, let's say 20% of the time, you're going to be using even less than 20% of the original energy. So how does the math work out on that? Well, 1/3 the energy consumption for 20% of the time. So what's that down to? We're down to, you know, just under 7% of the original energy consumption. It's a huge deal, okay? Being able to move to a system where we're drawing less energy, but we can also choose not to draw that energy at all. It just makes a massive, massive difference. So let's take a closer look at the ENSA LHB-D series of high bay lights. So there are 3 models in this range, a 100 watt, 150 watt, and 200 watt version. These lights produce 13,000, 19,500, and 26,000 lumens respectively. All of these lights are in the cool white color temperature. They produce a brilliant cool white light, 5700 Kelvin with a CRI of 80, which means that they look great. There is also no appreciable flicker and no noise. They are completely silent, okay? Unlike aging gas discharge lamps which flicker and sound horrible with that awful buzzing sound that I'm sure everyone knows what it sounds like. Everyone has experienced at some point in the past. They're really simple. There's only really 3 parts in these devices that come out of the box. So the first part is obviously the high bay light itself, okay? Second part is the hook, which mounts on the back of the high bay light, screws in like so. Like so. And the third thing in the box is the instruction manual, which tells you how to mount the light. As you can see, this light comes with a 3-pin mains plug and a 1.5 meter power lead. Now, this is notable because what it actually means is you don't need an electrical license to retrofit these most of the time, because typically high bay lights are actually mounted with base, like plug bases. They're actually plugged into plug bases. So you can just come along, unhook the existing light that's there, unplug the existing light, plug the new light in, hook the new light on, and you're done. It's a really simple installation, and obviously it gains you a huge amount of power savings just by replacing the lights. It's such a quick situation. These units are IP66 and including the cord, okay? So they're fine for outdoor use, no problems there at all. If you're mounting them under, say, a canopy or something like that, a tall outdoor canopy, that's typically where they're used outside. Out of the box, they come with a 90-degree lens, okay, 90-degree low glare lens, as you can see on here, polycarbonate lens. However, if you've got a particular situation where you've got a really high installation or a really low installation, so by really high, I mean probably above 10 meters, really low, I mean probably below 3 meters, we actually have the option of a 120-degree lens and the option of a 60-degree lens. So essentially, the wider you go lens-wise, the lower you can mount the device, and the narrower you go lens-wise, the more punch you get, so that you can actually mount them higher while getting similar luminance levels on the ground. These units all come with a 5-year warranty, and you can see the specs on the side of the unit here on this sticker here, but they all come with a 5-year warranty. Any additional specifications and things, anything else that you're interested in seeing is all on the RhinoCorp website. We'll jump across to here. So you can see here all the specifications, rhinocorp.com.au for all of the specifications for these devices. And there is also a complete data sheet that you can see here and browse to your heart's content and find out any specifications that I may have missed during this video. So there you have it, there's the ENSA LHB-D series of commercial high bay lights. Hopefully this video has been informative and you can see the savings that you can make just by replacing those wasteful metal halide lights with a more efficient modern alternative. If you've got any questions, comments, feel free to leave them down below. If you want to see all of our future videos, make sure that you get notifications for our future videos. Please make sure that you're subscribed and you click that little bell icon down the bottom. Thank you very much for watching.